This is Unit 3, Lesson 3, Introduction to Graphing Linear Equations. In the previous lesson, you were introduced to the slope-intercept form of an equation. In this lesson, we're going to be looking at it as a function which allows you to input a value and you receive an output. And this input and output can be graphed. So some of your objectives is that you can identify the slope-intercept form of a linear function as f of x equals mx plus b. You can graph a line in slope-intercept form and use the graph to show where the y-intercept b and the slope m are represented on the graph. And as a review, that you can define slope, y-intercept, and finally that you can graph an equation in slope-intercept form. Remember that an ordered pair is a pair of numbers used to locate a point on a coordinate plane. It's written in the form x comma y with parentheses, where x is the x-coordinate and y is the y-coordinate. An ordered pair gives you information about an input, the x, and its output, the y. When you have an input that returns one and only one output, it's called a function. An equation of any line is a function, if it's a straight line. As the operations of an equation are applied to the x variable, the input, the result, the output should equal y, which is sometimes written as f of x instead. That's pronounced f of x, not f times x. The following are both the same equation of a line. Y equals 2x plus 1. Or f of x is equal to 2x plus 1. If f of x is unusual to you, you can always just replace it with the letter y. An ordered pair is a solution with x value is inputted and the result is y. Let's take a look at something called the function machine. Think of an equation like the one that you see right here as a machine. A machine, or like a computer, that you can input a value and you get an output. Let's watch this machine work. I can plug any number or value I wish to put in for x. Let me just put in a number. Let's say 2. If I plug that into the machine spits out a 3. And you can see it's plotted there on the graph on the right. What if I change that x value to 5? Get out the machine a 6. So every time you plug in an x value, it goes into that machine or into that equation where you see the x. In this equation you have x plus 1. Well, 5 plus 1 is 6, so that's why the output was a 6. What would be the output if we put, say, an 8? Well, 8 plus 1 is 9. On the left, you see a t-table that started to form to represent all the ordered pairs of this linear equation. We can try another equation. Let me reset it. What if, let's say, we had 3x minus 2. And we start making our input values. Let's put in a 1. Put out a 1, and you get a 1 as an output. Well, that's because 3 times 1 is 3, minus 2 is 1. Let's try another value. How about 3? What do you expect the output to be? 3 times 3 is minus 2. So you see you get a 7. And you see the points start to plot. Eventually, when you plug in each value of any linear equation, it should always form a straight line, no matter what values you put in. Let's try a 2. And you see we get a 4. Notice that the dots are starting to make a straight line. I can put even fractions in. So 1/2. 0.5 is the same thing as 1/2. So you notice that it still forms that straight line. On the ECA, you may be asked to find several solutions to an equation or to a function. Here we have an equation, y equals 2x plus 1. On the t-table below, you are given various x values, and you are to find the y value. So if we plug in -2 for x, well, 2 times x, which we say is -2 right now, plus 1, what do you get? Well, it's all numeric. Now you have to follow the order of operations. 2 times -2 is -4 plus 1, and -4 plus 1 is -3. So our first solution is -3. Plug in your next value. What do you get? If you plug in the -1 or replace your x with -1, you get 2 times -1 equals -2. -2 plus 1 equals -1. Replace that x with 0. Two times 0 is 0. 0 plus 1 is 1. Watch what happens when I put in a positive 1. Two times 1 is 2. 2 plus 1 is 3. I get a positive 3. Plug in the next value of 2. 2 times 2 is 4. 4 plus 1 is 5. So all of those ordered pairs are solutions to this equation. Graphing makes it much easier to find several solutions like this. When graphing an equation, it's often easier to always start with the y-intercept. Remember that the y-intercept is the y-coordinate of a point when a line intersects the y-axis. In other words, when x is equal to 0 is the y-intercept. So which ordered pair below is your y-intercept? Take a look at the graph. When x is equal to 0, y is equal to 1. So the y-intercept is 0, 1. Remember that a y-intercept is a point. So when you ever are asked what the y-intercept of an equation is, make sure you write it as a point or as an ordered pair. The y-intercept usually is used as the starting point whenever you're graphing. If you recall, our equations of 3 forms of a line: slope-intercept form, point-slope form, and standard form. The slope-intercept form gets its name because the slope and the y-intercept is represented in the equation. It's whatever is added or subtracted to your x value. If someone were to ask you what is the y-intercept of the equation, it would always be 0, whatever your b value is. So that b is part or represents your y-intercept. Notice the other 2 forms of a line, point-slope form and standard form, do not include b in their equations. Therefore, it's not as easy to graph sometimes without knowing that y-intercept. This is why the slope-intercept form of an equation is most often used. If you can recognize an equation as in slope-intercept form, this could save you a ton of time when trying to find the y-intercept. Notice in our first problem that 2x plus 1 we already solved before. We plugged in that 0 and we got a 1. Well, look right here in the equation. Wasn't that a positive 1? And when we plugged in 0, we got positive 1. So without doing much work at all, when 0 in the second equation, when x is equal to 0 in the second equation, we can expect that its y-intercept is 2, just by looking at the equation. So our key concept here. In the slope-intercept form of a linear equation, the value that's in front of your x, if you remember the y equals mx plus b, m stands for slope. Again, if you're confused why they use the letter m, Montagna in Latin stands for slope. So that starts with M. The value that's added or subtracted to x, because that could be a plus or a minus sign right here. This value right here is your b value, or what's used for your y-intercept. Just keep in mind that the y-intercept is a point, and that value alone is not your y-intercept. You would need to write it as a point, 0, 6. Altogether, this is called because it contains the slope, and your y-intercept is how it gets its name of the slope-intercept form of an equation. Slope-intercept form. Once you know the y-intercept for a graph, to find any other point on the graph, you need to know the graph's or the equation's slope. Slope is the vertical change, or what we normally call the rise, over the horizontal change, or the run. When you do the rise, that rise could be a rise uphill or downhill. So think of it like rise or fall over run. Another thing I'm going to add to this note, and please write this in, is that when you're locating your next point on the graph, you're always going to run to the right. I will explain the only exceptions. So remember that slope, or M, is equal to your rise, we'll say or fall. So if you have a negative number, then it'll be falling, over your run, when you run to the right. This will help locate your next point on the graph. Keep in mind that also when you have a slope of 0, your line will be horizontal. If you have a division of 0, because you cannot divide by 0, it's a vertical line, or in your equation you'll see x is equal to some number. You won't even see a y. Look at this equation, y equals negative x plus 2. Sorry, I know the copy is a little fuzzy here. What would be its y-intercept? Well, 0, 2, the y-intercept. To find any other point on this line, you can quickly use the slope. Well, what is the slope of this line? Remember that the slope of a line is always the value that's being multiplied to x. Well, I don't see a number there. So what is it? If you don't see a coefficient of x, it is always 1. Now notice that it also has a sign. Don't forget that sign. So the slope of this line is equal to negative 1. Slope is represented often as a fraction, because remember it's the rise over the run. So how can you take a whole number and write it as a fraction? Slope is equal to negative 1 over 1. You just simply put a 1 under it. So if your slope is ever a whole number, just simply put a 1 under it so that you can figure out your next points on the graph. So to find the next point on the line, you would have a change or rise in y. Well, look at our change in y. It's at negative 1. So if we change our y by negative 1, 2 minus 1 is 1. Over our run, or change in x's. Well, look at your x value. It's a positive 1. If we change that a positive 1, we can find our next value. 0 plus 1 is 1. So 1, 1 would be the next point on the graph. To find the next point, you would follow the same pattern. The change in y is negative 1, that top number. 1 minus 1 is 0. Over change in x's of positive 1. 1 plus 1 is 2. And you can continue to follow the same pattern to find many points on your graph, which is a little bit easier than plugging it and solving it every single time. You just follow the same pattern if you know your slope. So starting from your y-intercept, I plotted the point 0, 2 there on the graph. 0, 2, That's your y-intercept. To find the next point on the graph, notice that our slope is -1 over 1. Because the top number is negative, that tells me I need to move down. Down 1, and then over to the right 1 to find the next point on my graph. And its coordinates is 1, 1. To find the next point, I have to go down 1 again, and over 1, over to the right or right over to the next point. So run right. And you notice that my point is now at 2, 0. Following the same pattern, you can find many points on the line. If you were ever asked to graph this equation, you would simply do just as we did here. You first plot your y-intercept, the +2, then use your slope to find more points on the graph. When you're done, you simply draw a straight line through them. Make sure you put arrowheads to show that that is the equation of the line. You would not leave little arrows to show how you used your slope to find the next point on the graph. You may need to back up, especially when you're noticing the next point on the graph actually goes off your graph that you have on your paper. So if you want to know previous points from your y-intercept, you would do the reverse. Because this was a -1, your top number was a -1, or your rise is -1. If we back up, or instead of falling 1, we go up 1, and then back up 1, or to the left. So this is the only time you would back up, is to the left. And you could find that previous point of -1, 3. If you did it again, where would you land? Well, if I started from the same point, that -1, 3, if I back up 1, or rise 1, and back up 1, there would be my next point on the graph. Draw my line and arrowheads to show my line is continuous. So why would I need to know that? I understand that this problem is not on your paper. This is just for me to demonstrate why we need to also know how to back up. In this equation, look at what is our y-intercept. It's always the value that's plus or minus the x. So that's our 8. So if we plot the point 0, 8, 1, 2, 3, 4, 5, 6, 7, 8, that'd be located right here. To find the next point on my line, I would need to know my slope. Well, my slope is 4. If I write that as a fraction, it would be 4 over 1. That means I have to go up 4 and run right 1. Well, if I go up 4, 1, 2, 3, you notice that I'm going off my grid. I can't plot a point at 4, 1. It's too high up. So this is an example where I need to back up. Because this is a +4 and a +1, the reverse of that would be a -4 and a -1. So if I fell down 4, 1, 2, 3, fell down 4, 1, 2, 3, 4, and backed up 1, I could plot a point right here. Again, I wouldn't draw my arrows to show how I got there. And then connect my 2 points together to draw my line. So that's why sometimes you'll have to back up. But typically you always rise or fall depending on if your top number is positive or negative, and then run to the right always. So let's practice graphing linear equations. Notice this equation is in slope-intercept form. Therefore our slope is equal to 1 over 4, the value that's in front of your x, and your y-intercept, or b, comes from the b value of the 4. So step 1, we need to plot the y-intercept. Remember, the y-intercept is at 0, whatever your b value is, 4. So we find 0, 4 on our graph. It's right there. Step 2, we need to plot your second point using the slope, your m value. So our m value is 1 over 4. That means we rise 1 and we run right 4. Rise 1, run 4, Always run to the right. So that's our next point. Notice I'm going from one point to the next from my known point, or my y-intercept. I don't start from my origin. I don't say, oh, go up, go up 1 and then over 4 from my origin. I start from my y-intercept. Connect the points. Normally you would want to use a ruler to make a straight line. Make sure you draw arrowheads to show that this line is continuous. On the ECA there is a line tool or line segment tool and a line tool. A line segment tool and a line tool. You need to make sure you click the right button to choose that you want a line that's continuous. Notice this line. Is it going uphill or downhill? If you need to check, write your name on the line, and it'll help you see if the line's going uphill or downhill. So this line is going uphill, so I expect my slope to be a positive slope. Is my slope positive? Yeah, 1/4 is a positive 1/4. So that's a way of checking your line, or checking is you look at your slope to check your line. Let's try another one. What's the slope of this equation? You say 1/2. And what's our b value? I'm hoping that you said -3. Don't forget that sign. Therefore, your y-intercept is located at 0, -3. Let's plot that. 0, -3 is located right here. Then what is your slope? Your slope is 1/2, or you rise 1 and you run 2. Always to the right though. So from my y-intercept, I go up 1 and over 2 to the right. Plot your point, and then draw a straight line to connect the 2 points together. That line represents all the solutions to this equation. Look at your third example. The slope on this line is 3. Your b value is 5, or positive 5. So therefore your y-intercept is located at 0, 5. If you plot 0, 5, that's located right here. Your slope is 3, but as a fraction that would be 3/1. That means we would want to rise 3 and run right 1. Well, if we start from our y-intercept and try to count up 3, 1, 2, when we get to the second count, you'll notice that you're off the grid. So we need to back it up. Do the exact opposite. If that's a positive 3, make it a negative. If the run is positive 1, then make it a negative 1. So we go down 3, 1, 2, 3, and back 1. So that's located right there. You can follow that same pattern down 3, 1, 2, 3 because it's a negative 3, and back 1 because it's a negative 1. To plot your points and draw your line. This is your last example before you'll do the group practice as your own independent practice. What is the slope of this equation? It is a -7/3. If you see a negative off to the side of a fraction for your slope, always put that negative sign with your numerator or your top number. The bottom number should never be negative. Your y-intercept, or your b value for your y-intercept, is at -3. Don't forget those signs. So that means your y-intercept is at 0, -3. 0, -3 is located right there. Your slope is -7 over positive 3. That means we have to fall 7 and run right 3. So if I fall 7, 1, 2, 3, oh, I'm off the grid. So what do I have to do? Back it up. Do everything in reverse. If that was a -7, I would make it a positive 7. Because that's a positive 3, I'd make it a -3. That tells me that I'd have to go to the left then. So if I go up 7 now, 1, 2, 3, 4, 5, 6, 7, and back 3, 1, 2, 3, should fall right there. Let me double check myself, but you look on your paper. 2, 3, 4, 5, 6, 7, yep, and back 3, 1, 2, 3. That's correct. I draw my line, put my arrowheads on it. Just to check my work, ask myself, is that a positive or a negative slope? Well, look at it. My name is going downhill, so I should have a negative slope. That means the number in front of my X should be negative, and it is. Always you look at the sign of your slope before you changed it if you had to back it up. Alright, try these on your own on your group practice.